Good afternoon, everyone. Thank you so much for joining us today. My name is Ashley Thompson. I'm a data scientist here with J.P. Morgan in the Applied AI and Machine Learning team, and I'm delighted to be bringing you today our final step in the data journey. Hopefully you've been following along throughout the week. Today we are talking about artificial intelligence. So really excited. We have two amazing subject matter experts with us today. We're going to tell us a little bit about this topic, which is, I think, funnily enough, called a brief spotlight on AI. As you will probably hear, AI is a massive topic. And so looking forward to hearing a little bit more about this and setting the stage for what we can do with some of these awesome technologies. Before I turn it over to our speakers today, I just wanted to say after we go through the session, we'll have time for questions. So please, as you are listening along and things come to mind, feel free to pop them in the chat window. There's a little Q&A box on your Zoom with a little speech bubbles. Feel free to put some questions there, and we will go through as many questions as we can at the end of the session today. So with that, I'm delighted to turn it over to Salim Faghali from Bloomberg and Daniele Magazzini from J.P. Morgan to tell us about AI. Over to you both.
Thank you, Ashley. Hello, everyone. My name is Salim Faghali. I'm a data analyst in the EU regulatory team at Bloomberg. So we're going to go over a brief spotlight of artificial intelligence and machine learning in this session. Now, hopefully, we're going to make the information non-technical and based on actual use cases. So can we get the next slide, please? All right, so before we define what artificial intelligence is, let's take a step back and consider the definition of intelligence. So if we define intelligence as the ability to learn or understand or to deal with new situations or triggers, then artificial intelligence would be the application of said traits on an artificial entity, right? Hence artificial intelligence. Now, artificial intelligence is an umbrella term, and within it, it encompasses things like machine learning, natural language processing, robotics, speech, and vision. Now, in the first part of this presentation, I will be focusing on machine learning and the different ways a machine can learn. And in the second part, Daniele will go through some specific use cases that I think you will find very interesting. Go to the next slide, please. So what is machine learning? Well, machine learning itself is a subset of artificial intelligence that allows software applications to become more accurate at generating outcomes through experience and data. Now, a machine can learn in one of three ways, or any of these ways combined: unsupervised learning, supervised learning, and reinforced learning. Now, if these terms sound familiar, that is because they actually also can apply to human beings. Now, as children, we learn through play. That would be very similar to unsupervised learning. And then at school, we are taught by a teacher. That's also very similar to supervised learning. And we also learn by engaging with our environment. So that would be also similar to reinforced learning. So now let's get to the next slide and discuss more each of these topics. So what is unsupervised learning? Unsupervised learning uses algorithms to analyze and cluster unlabeled data. And before we go any further, let's break that down a bit. What is unlabeled data? Unlabeled data is simply data that does not come with a tag that defines or classifies it. Right? So you could think of a picture of a dog without anything stating that this is a dog, right? Or an audio recording, or a news article with no actual topic. What unsupervised algorithms do is they take this unlabeled data and try to discover hidden patterns and similarities across this data set. Now, generally, you would use unsupervised learning for one of three main tasks. The first task would be clustering, whereby you are grouping data based on similarities or differences. Association, where you identify relationships across this data. And dimensionality reduction, It's very similar to when you basically try to improve the quality of a video, for example. Now, using these three main cases, you could then identify a couple of real life examples where unsupervised learning may be used. And these would be things like anomaly detection and customer, or in your case, it would be donor personas. Get to the next slide, please. So now we go to supervised learning. Now, supervised learning classifies data and predicts outcome. But the key here is it utilizes labeled data. So if unlabeled data is data that comes without any tag, labeled data would be the opposite. It comes with a tag that identifies its characteristics and features. Now, these sort of algorithms are generally used for two main tasks: classification. So for example, like classifying spam email, or sentiment analysis, which Daniele is going to go further into later on. And you also could use it for regression analysis. For example, predicting numerical values and outcomes based on historical data. So think about revenue projections and that sort of thing. Now, before we move on to the next slide, let's cover an important question. That question would be, okay, when would I use supervised versus when would I use unsupervised data? Well, to answer that question, you need to ask yourself three questions, really. The first question would be, do you have labeled or unlabeled data? And if you have unlabeled data, do you have the expertise to actually label this data? Second question you need to ask yourself is, do you have a recurring, well-defined problem that you're trying to solve? Or do you want the algorithm to simply predict? And third and foremost is, what options and resources do you have at your disposal, right? One thing to keep in mind is unsupervised data generally is computationally a bit more complex and requires larger data sets. Whereas supervised learning, on the other hand, leverages, you can run it off things like R or Python, for example. So these are three important questions you need to ask yourself before you decide on whether you want supervised or unsupervised learning. Can we go to the next slide, please? Right. Now we get to reinforced learning. Now, this form of learning revolves around an agent interacting with its environment, right? If the agent achieves a desired outcome, then there is positive reinforcement. If the agent achieves an undesired outcome, there is negative reinforcement. A simple way to think about this is teaching your dog how to sit, right? You do that through positive reinforcement, the treat. Same concept applies here. So some real life applications of reinforced learning would be text summarization engines, text and speech software that learn from user interaction. Now, one thing to remember here, there's a key difference between reinforced learning and the previous two methods of learning. And that is basically the previous methods look at data, and generally it's historical data, data that has been captured, right, to predict a certain outcome or to identify similarities. Whereas reinforced learning delivers decisions, right, based on interacting with its environment. Go to the next slide, please. Thank you. Now, which of these three methods is best? Well, that is really the wrong question to ask, because it depends on the problem you're trying to solve and the data you have at hand, right? None of the three techniques described are smarter than the other. Each has its benefits and each has its own drawbacks, right? Now, generally, a lot of processes will leverage two or maybe all three of these. So you'll go down the road of something called semi-supervised learning, where you have an unsupervised algorithm trying to identify similarities or differences, and a supervised one trying to predict outcomes. Now I hand you to Daniele, who's going to go through some explicit use cases where these can be applied.
Sure. Thank you very much, Salim. And hi, everyone. My name is Daniele Magazzeni. I'm AI Research Director here at J.P. Morgan. It's really a great pleasure to be talking to you today. So what I will do is to complement what Salim said in his great talk by presenting to you some capabilities of AI that can be then used in many different contexts, which are also very relevant to the audience of today. Now, as the title suggests of this session, this is supposed to be a brief spotlight on AI, given that there are so many different AI capabilities that we can talk about. As Ashley said at the beginning, is a massive topic. So there will be really a lot to say about AI. But I decided to focus on a couple of capabilities that I believe are more relevant to nonprofit organizations. In fact, AI, as you can imagine, can be used to improve efficiency in organizations and also to free staff from administrative tasks so that they can focus on other activities that are more important. But crucially, in the context of nonprofit, AI can be used to literally reimagine the relationship between the nonprofit organizations and the many stakeholders, starting from donors, first of all. Now, the two capabilities that I'm going to talk about are, first of all, AI to understand the natural language and text, and then AI for process optimization and resource allocations. So if we go to the next slide, please. Okay, so AI can understand text, and this is an important capability of AI, which very many applications in many domains. I'll describe here, first of all, a project we run here at J.P. Morgan, which is, however, general and again can be applied to a variety of domains. So our goal in this project was to be able to extract sentiments from any topic on social media. And this is an issue called, or a challenge called sentiment analysis, which is becoming more and more important given the huge amount of information that is shared on social media, but also because of, as you might have heard, there are episodes where a few tweets can have a huge impact, for example, on impact on markets. So to be able to some extent to monitor what's happening in the social media is very important, and AI can help. So what we did in this particular project was to obtain data from Twitter via their APIs. So this is something that everyone can do. And then we build a sentiment analyzer. In particular, the sentiment analyzer we built is aspect-based. What it means is that the analyzer is able to categorize each tweet by aspects. I'll talk about this in a minute, and then assign a sentiment to each aspect. We'll see again a concrete example in a moment. Now, here by aspect, we mean entities that could be names or topics more in general. Now, without being too technical, I'd like to give you a sense of how AI can address this type of challenge. And you see the 4 blocks here in this slide. So the first step is to be able to pre-process the data. And during this journey this week, we went to some of these steps of what it means to pre-process data. In this case, the pre-processing we did include tokenizing, lemmatizing, and removing stop words. So it means to categorize part of the text that we gathered. After that, we performed the so-called POS, that stands for part of speech tagging, which is a grammatical tagging that assigns words saying this is a noun, this is an adjective, this is a verb. So a grammatical analysis of the sentence. And in this way, we move into the third block that allows us to obtain this lexicon dictionary that contains words and their sentiments. By the way, an interesting feature is that given that this project was around text in the social media, this approach can also provide sentiments for emoticons, which are widely used in social media. And this is a very nice feature to, again, to try to get a sense of the sentiment in the social media. Then the last step is basically to split the sentence and assign a sentiment to different features so that ultimately we can calculate a final sentiment to each aspect. Let's see a concrete example. If we go to the next slide, please. Okay, here it's a simple example, which, however, I hope will convey the capability behind this project. So let's assume we have a generic tweet, say company A is doing well, but company B is performing terribly. Now, what the algorithm, the AI does is, first of all, to identify the aspects. And in this case, we have the aspects of company A and company B, and then expressions that refer to sentiments, such as doing well or performing terribly. And the output of this technique is then to match and assign a score, whether positive or negative in this case, to each of the aspects. So as you can see here, is clearly easy to say that we have a positive assessment for company A and a negative one for company B. Now, to note that in this first example, the sentiment expression are directly related to the aspects, to the company. However, if we look at the second tweet, we say Good Water Aid, which is a name of a potential company, organization, provides clean water to communities. Now, in this case, the sentiment expression, which is clean, is not directly related to the organization, but to water. However, what AI is able to do is to identify this kind of connection and still, in this case, assign a positive sentiment to the Good Water Aid organization in this case. Now, one important point I want to highlight is that these two examples can look quite simple and trivial. However, I guess the most important power of AI is the ability to scale, meaning to be able to handle huge amount of information. Now, I don't know if you are, and I mean, this is fascinating to me. Now, I don't know if you have an idea of how many tweets are tweeted per day. It would have been nice to have a full question for this, but I'll give you some numbers that are quite impressive. So on average, and this is a very recent information, on average, every second, there are 6,000 new tweets every second, which means that every day we have 500 million new tweets. So you can imagine the huge source of information that social media is. And these numbers, by the way, only relates to Twitter. So if you put other social media as well, you see again, the huge information that you find in social media. So to some extent, to be able to capture trends in social media can have really an important impact on how organizations, companies perform. And also in this case, you might expect to have several thousands of tweets related to company A and company B in this example. So it's also important to be able to collect information and average what the sentiment analyzer is finding across several tweets in this example. Now, how can this capability be helpful for nonprofits? Now, I don't pretend here to be exhaustive. There are few examples. There will be many others, but I think it's important to help everyone get a link on this AI capability and how these can be used by nonprofit organization. Now, one way that sentiment analysis can help in assessing the level of engagement when you look at different campaigns that your organization is doing, for example, a fundraising campaign or a campaign for raising awareness. In this case, what the sentiment analysis tool does is to basically, for example, monitor comments and responses to posts so that you can assign sentiment accordingly. So again, even being able to analyze the interactions of users in social media to response, comments, likes, and things like that, you are able to assess the level of engagement. Another way is to identify user needs and the contents people are interested in. Now, the reason why this is important is that you can identify the content which is most interesting for users so that the campaign can be customized and tailored to the right users so that the campaign itself is more efficient. Another way to use sentiment analysis is to compare sentiment to other peers in the sector. So what you can do is that you compare sentiments with other similar organizations and see how yours relates to the other and make comparison between peers. One more thing is identify the target audience for campaigns. In this case, you can, for example, identify the user who are most engaged with some topics and decide to target this user with specific campaign. Also important to mention, I guess, that sentiment analysis is also used to protect reputation, in the sense that you can automatically detect negative opinions in real time, so that you can, as quick as possible, be able to proactively respond to this negative and perhaps take action to improve. Now, another important application of this AI capability of AI understanding text and processing natural language, which I think is very relevant for non-profit organization, is the use of AI for donor retention, and also to identify prospective donors, future donors. In fact, given the focus of a non-profit organization, AI tools can really help in automatically or semi-automatically identify prospective donors on, for example, social media platforms, again, but also other public sources of information. At the same time, similarly to what we said with the customized campaigns, an AI can also analyze data about donors and suggest how to improve the communication with them and to personalize and customize the communication with these donors. There are a few examples of tools that people can look at. One example is, among many, one example is Gravity, and this tool, what it does is to draft automatically emails to existing donors. So you have a list of your donors in your current organization, and this tool helps you draft emails to each of them in a customized way based on preferences of donors or the previous actions of these donors, and also highlighting donors who are no longer engaging, so that you can be flagged that perhaps this donor needs to be contacted as soon as possible. An important point is that this tool, in this case, still wait for humans to approve the email to be sent. In this case, AI is not replacing human, but instead AI is being an assistant for humans, with the goal of saving time on one end, saving a lot of time for people, and also to make the communication more efficient. Now, another tool, which is also quite powerful, give you the personas of your current donors, together with insights and analytics. Again, the goal of this way of using AI is to try to be as more efficient as possible in communicating with your existing donors and looking for new donors as well. Now, if you go to the next slide, please. Now, I won't spend a lot of time on this slide because we had a very nice session on AI for data visualization yesterday. However, I thought that it was important to recall this capability in the context of AI reasoning with text, because clearly when it comes to text, there is always the issue that there is a lot of text out there. And so it's important to talk again about visualization, again, in the context of how to make sense of vast amount of textual information. Now, again, think about the number of tweets I mentioned earlier, right? Several hundreds of millions every day. So it's important to have an efficient way to summarize the information and help humans make sense of this information. Now, this is based on a project we run here at J.P. Morgan. As you can imagine, here at J.P. Morgan, as in many other companies, we have a lot of text documents, whether they are regulations or reports or interaction and communication, lots of textual documents. And we often need to tag the documents with labels so that we can organize the documents based, for example, on their structure, on their topics, so that, and this is a crucial challenge in large organizations, so that people can search and find the right document as easy as possible. So we want to really help our colleagues to find the right document in a very efficient way, without having to spend a lot of time in searching among this huge amount of information. So to do that, and this is where AI can help data visualization, we can combine the pattern recognition of AI, which means AI able, as also Salim was saying earlier, the ability of AI to recognize similarities between, for example, concepts in a textual document. And we combine the pattern recognition capability of AI with visualization, which is an important ability of humans, as to create a framework for allowing user to navigate the space of information. Now, in this example, you see these nice color figures, but actually they are AI generated. Again, without spending too much on each of them, but just for you to be aware of the opportunities that AI offer for data visualization. We have word hypergraph, network graph, and hierarchical organization. Now, in the word hypergraph on the left-hand side of the slide, instead of the typical word clouds that you find quite often, even in the web, the idea here is to use a graph structure to identify words that are central to a corpus of documents. In this picture, for example, you see that the word flight or the word judge in the respective set of documents are very important as they are connected to many other words. So this gives you the relevance and importance of each word. In the network graph in the middle, the documents are centered around their corresponding cluster, meaning documents that somehow relates to one same aspect. For example, in this picture, the green dots are related to clients-related documents. And this, again, gives you a nicer or granular view of all the documents that you have to deal with. And even if this seems to be its a static image, you need to think that you are able to zoom in and out to get more insight into each of these clusters. And finally, in the hierarchical organization on the right-hand side, this gives you a sense of the relationships between documents to gain granular insights. For example, here in this picture, each circle denotes hierarchical level, and circles around the same parent are more similar. Once again, these are static pictures, but the framework allows people to navigate, zooming in and out and moving around to get a global view of the set of documents users are dealing with. Okay, let's move to next slide, please. Right, now, I'd like to mention two more ways NLP, that stands for Natural Language Processing, can be useful, I guess, for non-profit organizations. First of all, chatbots. Now, chatbots in general are a new, very powerful way of getting information. You ask questions and you get answers. The only difference is that it's not a human answering, but it's a machine answering. It's really growing, the use of chatbots everywhere, really. For sure, it happened to many of you that even when you access a website, very often there is a chatbot popping up and offering help. So in a sense, customer service is offered many times by chatbots, again, which are AI driven. Now, non-profits are also appear to be quickly adopting the use of chatbots. And the main idea being that chatbots increase the ability of non-profit organizations to interact and engage more with supporters and donors. Because, I mean, chatbots can operate 24/7. So almost without no cost, because they are not expensive, and they can answer many questions and again save time to staff who can instead dedicate their time and their effort to other tasks. There are again many examples of chatbots being used by non-profit organizations. Just to mention one among many, there is the climate reality bot, which is designed to educate supporters around the climate reality project. And also what this chatbot does is that builds the organization email list for action alerts based on people who interact with this chatbot. And also, in general, chatbots are used to provide assistance to people who want to volunteer for, or people who want to help in fundraising. The idea then is that you can use chatbots to encourage people to become like champions for the projects by offering suggestion and way they can engage. Again, in a basically automatic way. So you no longer have a human having to reply to all the queries, but you have AI instead. Another example is, again, among many, is Ellie Chatbot that help housing associations and councils and charities to support vulnerable residents. The idea there is that citizens can access information and get advice through their phones and at any time. Again, there are many other examples of how chatbots are used. And one more thing I want to stress is that building chatbots is quite simple. There are a lot of resources, even on the web, that allows you to quite simply create a chatbot for your organizations or for your need. The other way NLP can help, I guess, nonprofits is AI storytelling. Again, I will not spend too much time here because yesterday we had a fantastic session where Jonathan Hord talked about AI for storytelling, so it was really brilliant. I want to reiterate that AI can help, particularly in increasing awareness, raising awareness around specific topic, attract the attention of potential or prospective donors. For example, by knowing the demographics and affinities of your current donors. So by looking at current donors, you can explore new potential donors and also to tailor and customize the campaign and the way you should approach those donors. There are tools available that, for example, recommend the right content to include in fundraising campaign. And this recommendation also includes, for example, writing style or which specific question you should ask, and even subject lines to test. So the idea is that AI can enhance the ability to reach out to donors in a more efficient way by targeting and customizing the communication with them. And there was a report from last March I read recently saying that the use of AI for storytelling has dramatically increased the conversion rate of one-time donors to monthly donors. So I really recommend to look at how you use AI, again, for chatbots and for storytelling. Let's move into the next slide, please. Okay, now, so far we spoke about AI for understanding text and reasoning with text. There is now another capability I want to spend some time on, which it's very general and finds application in many different domains, which is AI for resource allocation. So this seems to be a quite technical slide, but it's easy to follow. Let's go together through this diagram here. So first of all, the input in a resource allocation problem is given by resources you have to allocate, and then you have a set of hard constraints. Hard constraints means those constraints must be satisfied. There is no way you can go around those constraints. But you also have a set of called soft constraints, or also called preferences, that you would like to have, but it's not so mandatory. And then you have a time window. So I want to allocate resources for the next month, or for the next year, or for the next couple of days. This is the input for the AI for resource allocation system. And what the AI does is to reason with the resources you have to allocate on one end, all the constraints that you have, and try to come up with either an assignment that satisfies all the constraints, and this is the output one, that gives you actually the right way or the efficient way to allocate resources so that all your constraints and preferences are satisfied. Or there might be the case where there is not such an assignment, for example, because you have not enough resources or not enough availability. And in this case, what the AI can do is, on one end, suggest how to relax some constraints so that a feasible assignment can be found. Or the AI can tell you which additional resources you need so that you can satisfy the constraints. Now, let's see a concrete example. If we go to the next slide, please. Okay, now this is based on a project we run here at JP Morgan, where in this now returning to the office after the pandemic, we have the problem of understanding how to rotate teams in the office, given that we have a limited number of desks, and we also have preferences for employees and our colleagues on flexible working. So let's try to see how the general AI formulation I showed before, how this applies to the concrete example of organizing the flexible working. So in this case, the input is given by, so the resources to be allocated here means the employees and the number of desks we have available. That's the first input. The set of our constraints is, for example, the minimum number of days per week each employee wants to come to the office. Soft constraints can be, I like to work from home on Fridays, for example. And the time window can be, okay, let's plan for the next 4 weeks. So the AI takes all this information into account and either gives you, and this is option 1, a feasible assignment saying when I should go in the office, where my colleagues should go in the office every day, everyone should go when. Or alternatively, the two possible alternative outcomes are either say, you know, based on the desk you have, either you reduce the number of days that employees must go to the office, or you increase the number of desks so that you have more options for people to come to the office. Let's go to the next slide. Here you see what it means, as an example, again, what it means to specify constraints. In this case, as examples of constraints, people can, for example, a group manager can specify minimum or maximum number of days per week, what are the preferred days for every team member, and also what are the working groups, which means if you have people working on the same project, ideally you would like them to be in the office on the same day so they can work physically together. You can also specify days where people must be in the office because, for example, you have workshop, and many more can be included. So the reason why I wanted to show this slide is that clearly this is an example for flexible working, but you can think of any problems in your organizations where you have this type of scheduling problem or resource allocation problem, and the same capability can be used easily for your problem. And I guess the beauty of AI here is that really AI allows you to describe a huge amount of constraints. You can specify very important, particular constraints and ask the AI for the solution. The alternative would be Excel, for example, or a spreadsheet or manual scheduling of people, which, however, is time consuming and also often is suboptimal. Let's see the output of the AI. If we go to next slide, please. Right, now what you see here is basically the output of the AI being a schedule. Here, each column corresponds to a day of the next month, of June actually, and each row corresponds to an employee, and colored cells means where that employee should go to the office. And in colors, you see people in the same working group. So what the AI is trying to say is that, okay, I try to have people working on the same projects in the office in the same day, okay, given again the number of desks and the limited availability and all the other constraints. An important thing I want to stress here is that using AI, you can easily analyze what-if scenario, which means what if I have more or less desks? How the solution would change? And this, I think, is a powerful tool because very quickly you can easily analyze different ways of finding a solution. One last thing I want to say, which I hope it was clear from this talk, is that we talk about AI capabilities, which means you can use the same AI we talked about, for example, for analyzing tweets for social media on other contexts, or chatbots can be used for a variety of different domains. And this AI for resource allocation, again, can be used for a variety of different problems. So in this sense, you should think about, okay, the capability we discussed this today, how can they be used for some problems I'm facing in my organization? In this sense, it's very general AI, and this is, I guess, fascinating. Okay, I think I'll pause here. I think we have one next slide with some resources, maybe, where we listed a few of them. Okay. But clearly the web is full of AI resources, material that you can read about, but also tool you can download and use. Again, I would mention for chatbots, there are a number of resources where you can download a framework that allows you to create easily a chatbot for your needs. Similarly for storytelling, and also for the machine learning techniques that Salim spoke about earlier. And finally, for this constraint satisfaction problem or resource allocation problem, there are open source tools that allows you to specify constraints and provides you with a solution. And I will pause here. Thank you very much.
Fantastic. Well, thank you both so much. I think I am definitely struck by not only, I think, how broad this topic area is, but also like how many different kinds of problems and scale that we can get from some of these capabilities. So thank you so much for that overview presentation. We have a ton of questions. So again, we'll go through as many as we can. As we sort of go through this discussion, again, encourage the audience to keep popping in questions to the Q&A section. Hopefully we will get to all of them. I guess one of the questions that comes to mind, and I think is really of interest to this audience as well, is, you know, yes, we can see the power and what AI can do, but do we always feel like we can trust what these kind of capabilities are doing and showing and telling?
I'm happy to take this one first, actually, then Salim can jump in. It's a brilliant question. It's a question we also face doing as AI researchers. I guess the issue is that in many cases, the AI gives you the solution or tell you something without telling you why, okay? Without providing reasons why the AI comes with an answer or a solution. Now, that's an important challenge for AI. However, in the recent years, there is a growing research activity in AI, which is called explainability, whereby the goal is really to try to explain, as the word suggests, the behavior of the AI system. Now, this is a difficult problem. It's not at all an easy problem. It's difficult, but some progress has been made. A couple of things I can mention without being technical is that, for example, when you have a lot of data and the AI, again, as Salim was mentioning, process all this data and come up with a recommendation, for example, okay? What you can do is to identify what are the features in the data that you are using that are most important for the decision that the AI makes. This is called a feature importance. You have a lot of data, including many features. Okay, there are techniques that tells you these features, for example, the geography or some of these features are the ones that drive the most the AI model. Another approach, actually something we are doing here at JP Morgan, is in fact checking. So there are AI systems that are responsible for telling you whether a fact is to be considered true or false. And explainability in that context means giving you some evidence on why some fact must be true or false. And similarly to explainability, there is the concept of, which is in back to the question that Ashley asked about fairness, right? So not just allow to understand whether I should trust AI in that what is saying is true or false, but also is fair what the AI is doing, and or, for example, there are bias or any sort of discrimination in the data that you're using. These are very important concerns, and there are a lot of research going on this space. Even at J.P. Morgan, we created the Center of Excellence on Explainability, exactly to address this type of challenge. And to give you a concrete example, which you will find very concrete, when we use this AI for flexible working, for how people should rotate, clearly an obvious question is the schedule fair? For example, we don't want the same people to go on Fridays in the office every week. Okay, so we want to make sure that there is a balance. These type of questions, which are important questions, and are also difficult to answer, but there is definitely a lot of research going on in trying to explain the AI so that, as Ashley was asking, you can go towards trusting more, or at least increasing the confidence on the AI that are using.
Yeah, I think that's so interesting. And, my take on this is that something like AI, we never originally thought about things like fairness or bias or all of these sort of other considerations, which have really come to the forefront. And I think it's exciting to see the academic community and really spending a lot of time on these really challenging, not easy to answer sorts of solutions. So I think this is an emerging area that will continue to grow and evolve. But I think ultimately, from a societal perspective, will end up better. How are we removing some of the biased choices that we as humans have been doing, and how do we, create more opportunities for fairness and different decision making? I guess sort of as a corollary to that, I'm interested in both of your perspectives on, and I think you both touched on this to some extent during your presentation, but is AI a replacement to humans?
Well,
I leave to Salim to answer first.
Yeah,
Please,
thank you, Daniele. That's a great question. I think there's a lot of fear in society today that we're going to all be replaced by robots. I think the important thing here to identify is that AI is a tool that will assist us to become more productive and more efficient rather than replace us. Basically, it'll free resources for us to focus on things that require more human intervention rather than just replace us altogether. So an example at Bloomberg is we used to spend a lot of time actually trying to take information from documents and put them in the database. So basically extracting data from documents. And then with AI, actually this has now been done automatically through an algorithm. And what we do is more actually QC the results of that AI rather than actually spend a lot of time doing the actual work of taking the data and putting it in the database.
And yeah, I completely agree with everything Salim said. I will just add on top of that no, AI is not going to replace humans. We hope that AI can replace a lot of spreadsheets and manual documents, right? That's definitely something. The idea is to empower employees, to help them focus on what is more demanding from human judgment point of view, for example. I also like to mention one example. In JP Morgan, we are trying to use AI to agentize as much as possible policy compliance. So how to come up with a way of representing the regulations that a machine can understand so that they can help the compliance teams. Of course, there are many things that AI cannot do. Many regulations requires human judgment. However, the AI should be able to identify those cases for which a human is needed and say, okay, I cannot deal with that. This goes to humans. I will focus on these others that AI can deal so the humans can focus on something more important for humans to intervene.
Thank you both. I love hearing different perspectives on this particular question, and just in sort of my own thought process or experience around these issues, I think it's really important that we're spending time in defining, tasks that humans are good at and should keep focusing on, tasks that really humans are okay at, like probably maybe a lot of times they're not even that good at those tasks, that machines are so much better at doing, more efficient. As Daniela, you were talking about chatbots, cheaper. We can just do a lot more with sort of less resources. And then there's sort of a third category, which is the combination of machine and human together. And I think there's been a lot of interesting research that is like so much more powerful than either things on their own, and sort of the human AI interaction. So uh, love hearing your perspectives on that. Thank you so much. Um, I'm curious, you mentioned a couple of sort of initiatives and things around this, but can you think of or demonstrate for this audience, a couple of other AI programs around social good?
Uh,
Oh,
Sorry,
please,
go ahead, Daniela.
please, Salim, you go.
Well, there are a couple of programs out there. I believe I think it's the Heart British Society is now working with an institute to actually work an algorithm that helps better diagnose people at risk of heart disease. Right, that is one example. There are also a couple of examples I think Daniela touched on during the presentation about donor-specific implementation of things as well. So it's really AI is a huge universe. So it's about actually finding these problems and identifying them, and then having AI target these problems.
Yeah, and I would add on top of that, there are many, as Salim was saying. Even in the UK, we have the Alan Turing Institute, who has a AI for Social Good program. So I recommend to have a look there. And also there are also larger programs, say from Google or IBM, focusing on AI for Social Good. I'd like to mention that even in JP Morgan, we have an AI for Social Good program. And one recent initiative we are moving forward is AI for Africa, where the goal is to help people in Africa get more familiar with AI in terms of education and providing support and even infrastructure for improving and increasing the familiarity of with AI with people in Africa. And there are also other initiatives that JP Morgan is doing. But yes, I mean, I'm very happy to see that there is a lot of focus and interest in AI for social good. And one last thing I will mention, there is also a academic conference which is called AI for Social Good, which is run every year and tries to really foster the research on how AI can help worldwide from a social point of view. So definitely an important topic.
Thank you both so much. Tons of great initiatives going on here, which is fantastic. And I'm struck actually, as you were both discussing sort of some of these things with it, one of, I think, the best things or, big selling points around AI is it enables you to do more or to think differently around things that we've done for a really long time. And I think that those goals and motivations are relevant in every sector that you're looking at. So it's amazing to see, some increased focus in those areas. I have one last question that I'll leave both of you on. But before I do that, I just wanted to quickly mention again around our closing session later this afternoon at 3 o'clock. It's going to be absolutely fantastic. We have Giselle Corey, the Executive Director of DataKind UK, who's going to be giving a keynote. And then opening up for a panel discussion with 3 amazing nonprofits. So we'll have the Fair Education Alliance, Zero Gravity, and the Felix Project. So a really great panel discussion there. And then finally, we'll have Gideon Mann, who's the head of data science for the Office of the CTO at Bloomberg, as well as the founding member of the Data for Good Exchange to close the event. So keep looking forward to seeing you all there. That's 3 o'clock UK time this afternoon. And I think it's going to be an amazing session. Before I let everyone go, and I know there's tons of resources, things about this, but I'm curious to hear from both of you. If you had to start somewhere, look at one thing, one resource, one blog post, one course, What's your snap decision answer on a great place to start around this topic?
Salim, you go first.
Sure. That's a great question. Honestly, there are tons of resources out there. It really depends at what level you are when it comes to general data science and statistical analysis. One resource I found very helpful, but then it's a bit technical though, is the MIT Open Course. There's also Bloomberg GitHub AI application as well. So there's really a ton of research. There's plenty of courses out there by companies like Coursera and Udemy and so forth. So it's really a jungle of resources.
Yeah, I completely agree. There is tons of resources. Perhaps given my academic background, and I'm biased here, one thing I would suggest is to look at the conference I mentioned earlier, AI for Social Good. That gives you usually also tutorial for people who are approaching AI for the first time, in a sense. And that could be also, a guide towards, for people who are interested, finding more detailed resources and follow up on them.
Amazing. Thank you both so much for your time today. To the audience, thank you for your time. Thank you for your questions and your engagement. We're looking forward to following up with you and again, seeing you in the closing session at 3 o'clock today. Thank you. Have a great rest of your day.